In this lesson, you will learn to find a formula for the nth term of an arithmetic sequence and to find specified terms of arithmetic sequences. Now, as we begin, we have our first example where we can tell the pattern is adding 4 every time. We have 3 plus 4 gives me 7, 7 plus 4 is 11, and etc. And the question here is, what is the 100th term? Now, yes, we could keep adding 4 over and over again, but that's going to take a long time, especially if you're trying to find even a bigger term number, say like the 1000th or millionth term. So we want a short way to get the solution without having to add over and over again. So what we can do is we can see the fact that each time we are adding 4. We add a 4 to get from 3 to 7, from 7 to 11, and etc. Now the question is, if we start at 3, how many times will I need to add 4 to get to the 100th term? Well, this is your first term. So to get to the second term, you're adding 1 4. To get to the third term, you're adding 2 4s. So the number of times we're adding 4 would actually be 1 less than the number of terms that we have. So we're going to be adding 4 actually 99 times to get to the 100th term. So we add 4 99 times. So if we take 3 and we add 99, or 4 99 times, what we have is going to be 3 plus 396, which gives me a solution of 399. So now to generalize what we just did, to find some term, so to find some term number, so Tn would be just any given term, we took the first term, so 3, which we can use the letter T with the 1 underneath to represent term 1, plus, and then the 4 is your common difference. So this 4 would be your common difference, and the 99 we found by taking 100 and subtracting 1. So whatever the term number is, so we'll use the letter N to represent term number, whatever that is, we subtract 1 and multiply that by your common difference, and that together will give me any term number. So my equation that I can use for any arithmetic sequence is right here. Now, looking at the same sequence, what if we wanted to find some other term? Well, yes, we could use the equation and plug in the first term, plug in n, which is the term number, and plug in d, which is the common difference. However, it'd be nice if we could just have an equation where I only plug in just the term number that I'm trying to find. So we can actually do that, where we can plug in everything except for n. So if we plug in t1, which is term 1, and then plug in d, your common difference, t1 is 3, your common difference is 4, because we're adding 4, we would have 3 plus n minus 1 times 4. Where if I distribute, I get 4 times n and 4 times negative 1 to get 4n minus 4. Combine the 3 minus 4 to get negative 1. So this equation, Tn equals 4n minus 1, is an equation that we can use where we can solve for any nth term. Let's say we're trying to find the 200th term. Well, we can just plug a 200 in for n. We got Tn equals 4 times 200 minus 1. So now we have 799. We can now plug in any term number to find what is the solution. And so this is much quicker, and we can call this the formula to find the nth term. So if a question asks you to find the formula to find the nth term, all we do is use this equation, plug in everything except for the n, so that we can find the nth term with this new equation. Now I'm going to show you 2 examples where we use the equation to find a given term. Here we're trying to find the 17th term, which is what T17 means, given the sequence 5, 8, 11, 14, etc. Now to find the 17th term, we can use this equation, where Tn is the term you are looking for, T1 is term 1, or the first term, n is the number of terms that you are dealing with, and d is the common difference. So in this example, using this equation, t1 would be 5. That's your term 1. So t1 is 5. N is a number of terms that we are trying to find. So we're trying to find the 17th term. So n would be 17. And notice each time you're adding 3 to get to the next term. So your common difference would be 3. So you just plug everything in. 17 minus 1 is 16. 16 times 3 is 48. Then 48 plus 5 would be 53. Now just be careful, because if this were in descending order, so going from 14 to 11 to 8 to 5, etc., the common difference would be a negative 3. So be careful if it's going to be smaller numbers, because your common difference would be a negative 3, which would change your solution. Now this here is level 1 difficulty, and here is going to be a level 2 difficulty, where we are given two terms. So term 7 is negative 16, term 10 is negative 28, and our objective is to find term 21. However, given the formula, we don't know the common difference and we don't know the first term. But to find the common difference, what we can do is use the fact that there are 3 terms between term 10 and term 7. And then the gap between those two values, negative 28 and negative 16, you can find by subtracting the two numbers, and that's going to be negative 12. My common difference I can find by dividing the negative 12 by the 3. So the negative 12 by the 3, because there are 3 terms, and the common difference would be negative 4. And you can check that to see if that's true or not. Term 7 is negative 16. The next term, term 8, we find by subtracting 4, which would be negative 20. Term 9, we subtract 4 again to get negative 24. And then term 10 would be subtracting 4 again to get negative 28. So the common difference is negative 4. Now the question is, what is term 1? Well, I don't know term 1 yet, but what I can do is use the formula and plug in some things to find term 1. So the common difference we know is negative 4. We can plug that in. Term 1 we don't know. We'll leave that a blank. But if we can plug in something for n and tn, then I can solve this for term 1. Well, all n and tn mean is just a term number. So if I pick one of the terms that are given to me, let's say term 10, for example. If we were to take term 10, then in place of tn, I'd put a t10. And in place of n, I would put a 10. So in place of n here, I'd put a 10. So what I have is going to be t1 plus 10 minus 1 is 9 times negative 4. And that's all equal to t10. But t10, we already know what t10 is equal to. Whereas before, normally you try to find the missing term. Here we know t10 already, so we can plug that in because that is negative 28. 9 times negative 4 is negative 36. I can solve for t1 by adding 36 to both sides. And now I have t1 equals negative 28 plus 36, which gives me a positive 8. So now I know the common difference is negative 4. I know t1 is 8, so I can plug that in to find t21. So using the same formula, I repeat and plug in now an 8 for t1, plug in a negative 4 for d, and then 21 is what we're trying to find. So t21 is going to have n be 21. So we have 8 plus 21 minus 1 times negative 4. So here, once again, the common difference, be careful with the negative 4. They don't make a careless mistake. But 21 minus 1 is 20. 20 times negative 4 is negative 80. And then negative 80 plus 8 would give me a negative 72. So term 21 would equal negative 72. And that concludes our lesson for today. We will see you next time.